Yes, kindly have your notebook with you. Um, so, in the previous classes, we have discussed about how to draw a DFA and how to draw an NFA, and we have also discussed the differences between the DFA and the NFA, right? So today I'll teach you the extended transition function for both DFA as well as NFA. Okay. So we have already discussed the definition for both DFA and NFA, and we have M is equal to Q sigma delta Q naught and capital F, right? So, and this delta is the transition function, and this varies for both the DFA and NFA, right? So, in DFA, we have represented it as Q into sigma gives Q, and so this is for DFA, and for NFA, Q into 2 power Q, right? So we have studied about both of these definitions in detail, and also the transition functions, and we have seen the examples for both DFA as well as the um, DFA as well as NFA. Okay. Okay. So here actually you will also get a sigma union lambda also. Okay. So we'll get the empty transition also, empty move also. So now what we are going to discuss is about if you're having any doubt or anything is not visible or any problem you have, you can just unmute your mic and you can tell. Okay. Extended for DFA. Okay. Extended transition function for DFA. So how this extended transition function is defined is, am I audible clearly? Yes or no? Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes. Okay. So the extended transition function is defined as delta star Q into sigma star gives Q. Okay. So what the meaning of this is that, so when we discuss about the DFA, the transition function would be something like delta of Q naught comma A is equal to, it goes to another state. Okay, so this is the current state, and this is the current input symbol that we are reading, and it goes to state Q1. Okay, so since DFA is deterministic, it has a determined output. Okay, so it will go to some particular state only. So this is the transition function of DFA, right? So here in the previous examples what we have discussed, we have read only one single symbol. Okay, in each transition function we have entered only a single input symbol. So what this sigma star represents is that, so this is going to be a string. Okay, this is going to be a string, and rather than a single symbol. Okay, so this is going to be a string instead of giving a single symbol. So once you give a string, okay, in this particular place, we are going to find out what is the value it will give or what is the state it will reach after reading the entire string. Okay, after reading the entire string, you have to check what state it will reach. What would be the output state? Okay, so that is what this extended transition function discussed about. So for example, let me take an example transitions. Let us take delta of q naught comma a is equal to q1. Okay, and let me take another transition function delta of q1 comma b is equal to q2. Okay, so let us take two transition functions, and so now so delta star of q naught comma ab is equal to what? Okay, so here we are asking about a extended transition function. Instead of having a single symbol, a string is given. Okay, ab. Okay, a string is given, so we want to find what is the output state. So what would be that? Can anyone guess from the given transition function? So what is the meaning of this is, so starting from state q naught, on reading A, it goes to q1. On reading from q1, on reading B, it goes to q2. Okay, so that means from q naught, after reading the entire input string AB, it is actually reaching the state q2. Okay, so this is what we are trying to find in the extended transition function. Okay, so we have transition functions for a single symbol. Okay, for individual input symbols we have the transition function, but when a string is given, so after reading the entire input string, what would be the output state? Okay, so based on this given input transition functions, we can say, so from q naught, first it reads input A. When it reads input A, it reaches q1 based on this transition function. Okay, and then from q1, it is reading the next input symbol, that is B. Okay, so what is the transition function given? From q1, if we are reading input B, then it reaches q2. Okay, so that means after reading the entire input string AB, it is reaching the state q2. Okay, so this is the extended transition function. So now this so this is by example I'm giving. So delta star, this can be recursively defined. Okay, this can be defined delta star of q comma lambda is equal to q. Okay, so the definition for, so if we have some input symbol, then it will state some other state. Okay, so but if you are reading an empty symbol, okay, empty string lambda, if you are reading an empty string, then the output state will also be the same state. Okay, delta star of q comma lambda is equal to q. Okay, so how, when a extended transition function is given, how we can write it recursively is that, so delta star of q comma wa, let us assume that the initial state is q and the input string given is wa. Okay, so this can be written as delta star of q comma w. So we need to read the entire input string, okay, one by one. So first let us start with w. Okay, so it means that it is not only two input symbols, it can have any number of symbols in the string. Okay, so the first symbol in the string we are going to first read. Okay, then the remaining will be available in the outer section. Okay, so this is how we are going to read. So this W again, it may be a string. Okay, so we are going to keep on reducing it until we get the empty string. Okay, so now this is how we are going to write it. So now we will write it for the given example. Delta star of Q naught comma AB. Okay, so this is the string we had. So how we can write delta star of Q naught comma A comma B. Okay, so now we want to know what is the value for this. Okay, so let me take this as an, so this is a let me take this as a first equation. Okay, so now in this we want to find out what is this value and substitute here so that we will be able to find the remaining thing. Okay, so let us find it separately, this one. So for your understanding only, I'm writing it separately. Then when you get practiced, you need not do it this way. You can directly, you will be able to do it in mind calculation also, you will be able to do it. Okay. So delta star of Q naught comma A is equal to, how this can be written? Delta of delta star of Q naught comma. Now, this input symbol, it cannot be splitted anymore. There is only one input symbol. Okay. So until you are having one input symbol, you keep on reducing it. Okay. So your input string may contain 4 input symbols or 5 input symbols, whatever it may be, 2, 3, 4, whatever the number of input symbols, you just keep on splitting it. Okay, so once you get the one input symbol, how that will be reduced, okay, or recursively, or how it can be written is, now there is no more string to be read. Okay, so this A can be splitted as empty string and then this input symbol. So now what is delta star of Q naught comma lambda? We have already defined it here. Okay, so delta star of any state comma input string will be that same state. Okay, so now what we are having here, delta star of Q naught comma lambda. So this would be Q naught. Okay, the value for this would be Q naught and this comma A. So what is delta of Q naught comma A? According to our definition, delta of Q naught comma A is equal to Q1. Okay, so now assuming that this is equation 2. Now this has to be, what is this actually? This is what we have found for this part. Okay, we have found it for this particular part. So we are going to apply it over there in that equation. So what will happen? Delta star of Q naught comma AB is equal to delta of, the value of this we have found it as Q1 comma B, that is equal to, now what is delta of Q1 comma B? That is equal to Q2. Okay, so this is what we have found it here. Delta star of Q naught comma AB is equal to Q2. So after reading that entire input string, to which state it will move on, where the automaton will be in, that is what we are finding it here. Okay, so if you have any doubts, you can unmute your mic and ask. If there is no questions coming up, I can proceed to the next topic. If you understand, you can put a just yes in the chat box. Yes, thank you, students. So now let us move on to the next thing, that is extended transition function for NFA. Okay. So now what we have discussed is for DFA. So next we will discuss it for the NFA. So NFA, as you know, it has some choice of moves. Okay, it is non-deterministic. There is no deterministic way to reach a particular state. So any transition you take, it may have more than one output states. Okay, so it may go to Q1 or it may go to Q2. Okay, like this, some possibilities are available. Some choices of states are available. Okay, in non-deterministic. So in the extended transition function for this NFA can be defined as delta star of Qi comma W. Okay, you can write it. See, the extended transition for transition function for NFA is defined as delta star of Qi comma W contains. Okay, why it is contains? Because it may contain more than one output state. Okay, so any choice may be made. So it contains Qj. Okay, these are all representative words only. Qi, Qj. Okay, so it may be any other state, Q0, Q1, Q2, like that. Okay, so contains Qj if and only if and only if there is a walk. You please make a note of this in your notebook so that you will understand when you read it. If there is a walk in the graph is nothing but the transition graph. Okay, in the transition graph, you want to write a transition graph. In the transition graph from Qi to Qj labeled W. Okay, so and this will hold true for, this holds for all Qi comma Qj belongs to capital Q and W belongs to sigma star. Okay, so let me explain. Don't worry about if you don't understand anything. Let us see one by one. So what is a walk? Okay, so walk means it is a sequence of edges. Okay, it is a sequence of edges. So for example, if you have some transition graph like this. Okay, now this Q0 comma Q1, okay, and then Q1 comma Q2. Okay, so this is a sequence of Q0 comma Q1 is a edge. Okay, and Q1 comma Q2 is an edge. So it's a sequence of edges. Okay, so now what is asked is, what is given here? So what will be the output of this thing? Delta star of Qi comma W contains Qj. Okay, so it is not only one state actually. Qj may be more than one. Okay, so Q0 may be there, Q1, Q2, anything may be there. So it contains Qj if there is a walk in the transition graph from Qi. So for example, let us take this is Qi and this is Qj. Okay, and if your string is 0, okay, if your string is 0, then that so in that particular walk, in that sequence of edges, if you are able to read the given input, okay, if you are able to read the given input string, then that edge will be added into the this particular output set of output states. Okay, so we'll see with an example so that you will understand it clearly. So take this example, Q naught A, Q1, Q2. Here it is lambda transition, and here also it is a lambda transition. Okay, so this is the problem we have taken. Now what is asked is delta star of Q1 comma A. Delta star of Q1 comma A. So we want to find the set of output states that will include for this particular transition function. So as you know very well that in NFA, we have this empty transition also, okay? Like in DFA, definitely you will be having a transition function for this, okay? From Q1, definitely there will be an outgoing edge for every input symbol given in the alphabet. But in NFA, that is not the case. There may be empty move, there may be empty transition, and so on, okay? So here you can see in the transition graph, there is no outgoing edge from Q1 for input symbol A directly. Okay, there is no outgoing edge for the input symbol A from Q1 directly. Okay, where input symbol A is present here, it is outgoing edge of Q0. Okay, and not Q1. So then how will we find it? Is there any actually a result for this or not? Okay. So what we are going to check is, see what are the states we are having? We are having Q0, Q1 and Q2. 3 states are there. Okay. So do one thing, check one by one. Okay. Check one by one. So this is our starting state now. Okay. So because the given transition function is Q1 comma A, transition of Q1 comma A. So you start your walk. Okay, you start your walk from Q1. Okay, and check whether you are able to, sorry, Q1. Okay, and you check whether you are able to reach Q0. Okay, and in that walk, if you are getting, if you are able to read that input symbol A. Okay, check one by one. So first let us start with Q0. Okay, and according to the transition function, you have to start your transition from Q1. Okay, so now you check from Q1, will you be able to reach Q0? Okay, and in that walk, whether you are able to read that input symbol A. So from Q1, by an empty transition, I am moving to Q2. Okay. From Q2, again from by empty transition, I am moving to Q0. Okay. And then from Q0 on reading A, I am again moving to Q1. Okay. Again from Q1 on making another lambda transition, I am moving to Q2. Again, I am making another, taking another empty transition move and going to Q0. Okay, so you can see here from Q0, Q1, I have reached Q0, though there is repetition. Okay, it doesn't matter. Okay, it doesn't matter. You can use any times this lambda edges in between your walk. Okay, you can read this, you can use this lambda transitions any number of times in between your walk. Okay, so now in this path, so that is what we have written here, from Qi to Qj. What we are checking for now, whether Q naught will be available in the output state. Okay, whether it will be present in the output state or not. Okay, so we are starting our transition from Qi, that is given. So delta star of Q1 comma A. So that is Q1 is according to us Qi. 2, we are checking for Q naught. Okay, so when you are checking, so whether in that walk, if you are getting that label, if you are having that input symbol or not. So now you can see here in this walk, you are able to read A along this walk. Okay, so all the other things are only lambda transition. Please keep it in mind, here in this walk, it should not involve any other input symbol other than lambda. Okay, if suppose if here if B is also coming, then that is not correct. Okay, so only any number of times you can use the lambda edges, okay, to have this kind of walk. So now it is possible that from Q1 you are able to reach Q naught by reading input symbol A. Okay, so we are adding Q naught to our output states. Okay, now you again check Q1. Okay, so if you continue with this, you will be able to actually here itself you are able to get that. See here from Q1 to Q1. Okay, starting from Q1 and again it reaches Q1 itself. So, okay, so from Q1 to Q2 on lambda transition, again from Q2 to Q0 on lambda transition, and from Q0 on reading A, it goes to again Q1. So in this walk, it is able to read that input symbol A. So that means we can include Q1 also. We are able to reach Q1 state also. Okay. And the next one, you check whether Q2 is possible. Okay. So is it possible? If you continue the walk, what will happen? It will, you'll be reaching Q2. Okay. And in that path, you are again reading input symbol A. So starting from Q1, you are also able to reach Q2. And in that walk, you are able to read that input symbol A. So that means Q2 also you will be able to reach, okay, from Q1. So that means from Q1 on reading input A, I'll be able to reach all these three states, Q0, Q1 and Q2. So this is the output for this particular transition function. Okay. So if you understand this, can please put your yes in the chat box. I'll from this same thing, we'll find one more thing also. Delta star of Q2 comma lambda. Okay, delta star of Q2 comma lambda. So we want to find what is the output states, or what are the set of states that will come for this delta star of Q2 comma lambda. So like as we have discussed, from Q2 there is a direct empty transition move to Q0. Okay, so from Q2 on lambda it goes to Q2. So Q2 is included. Sorry, Q0. Okay, so from Q2 on reading lambda it goes to Q0. And also in these empty transitions, it without making any move or without making any reading any input symbol, it can reach its own state again itself. Okay, so without taking any move or without reading any input symbol, it is possible to reach its own state itself. So here Q2 will also be included. Okay, in the case of when you are reading lambda. Do you understand? If you understand, please put an S in the chat box. So we are moving, we are going to move on to another new concept. Yes. Very few are actually responding. I'm not sure whether all in the class are listening and taking notes. It would be good if you make notes. That would be helpful when you study for your exam. Yeah, thank you, Ma, for those who have responded. And I hope everyone understands. If you don't, please look into the video recording afterwards. So let me give you two problems, homework problems for this. You make a note of that and do it. And in the next class, you give me the answer for this. Okay, I'll give you the homework problem. Q0, Q1, and the initial state itself is the final state. Okay, this is the given transition graph. Now in this you find delta star of Q naught comma 1011 and delta star of Q1 comma 01. Okay, so this is one problem, and the second problem is, so after doing this, if you are getting any doubt, you can please ask. Please make a note of these two problems. Okay, so please make a note of these two problems and try to complete it. Yesterday also I told you that I will make a link in the Google Classroom, but I didn't do that. Today I will make a link. So you complete these two problems and submit it in the Google Classroom. Okay, just make a photo of it and convert it into PDF and upload it. Okay. Shall I rub this? Have you make a note of this? No. Quickly do it, ma. Which part you are not able to see? For others also, is it the same?
Hello, ma'am.
Yes. Jason, which one you are not able to see?
Ma'am, like not fully I can't see.
Yeah, which one you are able to see now?
Ma'am, now I can see only that SQ, then yeah, only
Not
those.
yes, that is delta.
Delta then Q.
Are you able to see what I'm marking here?
No, ma'am.
See, what about others? Are you able to see? Okay, Jason, were you able to see the first transition graph given here?
Graph also not able to see. Only I can see now only two circles, then two arrows, no, three arrows. That all I can see.
What about others? Are you able to see? Is it visible now?
I'm still
Yes,
seeing.
ma'am.
Kayuri, are you able to see both the problems and were you able to write it down?
Yes, ma'am. I wrote down, ma'am. I can see the whole chart also.
Okay. So, okay, Jason, I will put it in Google Classroom also. After that, you can make a note of that. Okay.
Now, ma'am, now okay, ma'am.
Okay. Okay, ma'am.
Now I can see.
Okay. Thank you, ma'am. So now we will move on to the next topic. So now what are all the things we have discussed so far is that we have talked about before that I'll tell you the Chomsky hierarchy, right? So in Chomsky hierarchy, we have talked about type 0, type 1, 2 and 3. Okay, we are going to I told you that we are going to study all these types of languages and the grammars associated with that and the machine or the automata associated with that. Okay, so what we are now studying is that the type 3. Okay, so type 3, that is the regular language. Okay, we have not yet entered into regular language, but whatever is concerned with regular language already now we have studied. So for representing regular language, we have NFA and we have DFA, and another notation is the regular expression. Okay, so all these three things we have now discussed. And so since all these things are representing only the regular language, there is a communication or there can be a we can convert one from another. Okay, so there is a link between them. So what are all the conversions we are going to study is that we will have we can convert from regular expression, we can convert it to NFA. Okay, so when a regular expression is given, it can be converted into an NFA, and when an NFA is given, it can be converted into a DFA. Okay, and when a finite automata or a NFA, you can say that. Okay, so when an NFA is given, that can also be converted into a regular expression. Okay, so the different conversions we are going to study. So now today we will start with the first one, that is a regular expression to NFA. So when a regular expression is given, how we can draw a NFA? Okay, so let me give you some of the okay, regular expression to NFA. So when we studied about regular expression, we have seen that there are some primitive regular expressions, right? Where there are some primitive regular expressions we have seen, and from that, using the operators like plus, dot, and star, we will also be able to create some more regular expressions. Okay, so we have seen that A belongs to sigma is a regular expression, and then lambda, okay, lambda itself is a regular expression. And then phi, okay, that is also a regular expression. And then so using the operators like plus, dot and star, we will be able to generate some more regular expressions. So if R1 and R2 are two regular expressions, then what we can do, R1 plus R2 is a regular expression, and R1 into R2. Okay, so it is not necessary that this dot can be put explicitly. Okay, you can just make R1 R2. So that is also again a regular expression. And then R1 star. Okay, this is again is a regular expression. So when we have been given such regular expressions, and also we know that parenthesis can also be used. So it can be like something R1 plus R2 the whole star. Okay, so it can be a regular expression, or you can write R1 plus R2 into R2 the R2 star. Okay, so that means here a dot is there. So this is also a regular expression. So when such a regular expression is given, how we can convert it into a NFA? Okay, so there are some basic principles for that. So that I will teach you now, and then we will move on to some problem. So first one is, so as we said, since A belongs to sigma is a regular expression, how any input symbol that belongs to an alphabet can be written as can be drawn as an NFA. Okay, so that could be just simply by having an initial state and by reading A, and it goes to final state. Okay, so this is the NFA for any regular expression, because A is itself is a regular expression. So this regular expression can now be converted into NFA like this. Okay, so from initial state, on reading that input symbol, it goes to Q1. Similarly for lambda, so lambda is a regular expression. So how we can draw for that? Q naught, okay, lambda transition, it goes to another state. Okay, and next one is empty language, right? Empty phi. So for phi, there is no connection at all. There is no input symbol. At least here there is an empty string. This is also considered as an input symbol. But for phi, there is no connection. Okay, so that means no connection between them. Okay, that is what the basic representation of NFA for this particular phi symbol. Okay, and this is for lambda. So this is for the primitive regular expressions. Okay, and we also have this R1 plus R2. Okay, so now let us see one by one for R1 plus R2, R1 into R2, and R1 star. Okay, so what is the meaning of R1 plus R2? It is union. Okay, either this or that, R1 or R2. Okay, that is the meaning. So how the NFA can be drawn for this is that, so this regular expression, it may be something. Okay, like this may be A plus B. Okay, and this may be C plus D. Okay, so anything, even some more complex regular expression can be there. So this is one regular expression, and this is one regular expression, and this has to be unioned. Okay, so how we can do that is, first, so we do not know what that is. So, but let us assume that that is having some thing. Okay, that is why I'm giving a curved line here. Okay, and this is not the actual final state, so that is why I'm giving here it as a dotted thing. Okay, this is not the actual final state. Okay, because still we have R2, and then we need to combine these two, only then you will be getting a final state. Okay, so this is for R1. Okay, so this is a machine for this R1. Okay, and so we are able to, we can draw a NFA for R1 separately. and also we'll be having okay, this is for R2, okay, M of R2. So this can be anything. So even if this can be R1 can be A and R2 can be C simply. So how will you have it? So you'll be having a and here you'll be having a C. So two different NFA drawn for the given regular expression R1 and R2. Now what is required? R1 plus R2. So how we can draw that is, you can have a common initial state. Okay, you can have a common initial state, and this state is connected with both the initial states of the machines R1 and R2 and connected by the edge lambda. Okay, and similarly both will be connected to a common final state using lambda transition. Okay, so R1 plus R2, that means starting from this initial state, either you can read this and reach the final state, or you can have this and reach the final state. Okay, so that is the meaning of this. Have the arrow marks here. Okay, so this is the NFA for regular expression R1 plus R2. Okay, and the next one is R1 into R2. R1 into R2. So similar to here, we can have different separate machine for this R1, okay, M of R1, and you will be having separate thing for R2, okay. Now, what is given? Concatenation, okay, R1 into R2. So, now you can have a common initial state, okay, you can have a common initial state, and these two can be combined together using a lambda transition, okay. So, the NFA for R1 and NFA for R2 can be combined together using a lambda transition, and then finally we can have a common final state, again that is connected with the using the lambda transition. Okay, so in the place of lambda, it can also be used epsilon also, both are same. Okay, so if your question paper, in your question paper, if you are getting epsilon instead of lambda, don't get confused, both are same. Okay, so in some of the problems it will always be used epsilon, okay, epsilon move, epsilon transition. So but the meaning is same, either you can use lambda or you can use epsilon, both the meanings are same. So when you have two regular expressions and you will be able to draw NFA for both of them separately, then when it is concatenation R1 into R2, you combine both the NFA using a epsilon move or the lambda transition, and you can have a common initial state and a final state. Okay, so this is R1 into R2. I think we are going ahead of time, so let me stop with this. In the next class we have one more thing, R1 star, so we will continue in the next class. I'll post the link in the Google Classroom. Kindly submit your assignment homework. Okay, kindly give your attendance mark quickly. ULK 1002. Give your attendance as I'm calling you. Don't leave the class. Please give your attendance when I'm calling you. Unmuting your mic and give the attendance. Don't leave the class. Preetham, 1001 Preetham.
Present, ma'am.
Shinoy.
Present, ma'am.
Jeffrey Jabastin.
Present, ma'am.
Ujjal.
Present, ma'am.
Nancy.
Present, ma'am.
Steve Abraham.
Present, ma'am.
Aditya.
Present, ma'am.
Soumya. Soumya, Joseph Rajan,
Present, ma'am.
Jeffin Thomas,
Present, ma'am.
Ashish Kumar,
Ma'am.
Varghese Shibu Shamel,
Present, ma'am.
Eirik Izan,
Present, ma'am.
Christina Sherin,
Present, ma'am.
Kayuri,
Yes, ma'am.
Sriram Prasad, Sriram Prasad, Justin Shan,
Present, ma'am.
Jemima Elizabeth Paul,
Present, ma'am.
Harsha Anna Daniel,
Yes, ma'am.
Jeffrey Roshan,
Yes, ma'am.
Naga Bhavani,
Yes, ma'am.
Christina Rajesh,
Present, ma'am.
Selvam Abhisha,
Ma'am.
Rajashekar,
Yes, ma'am.
Grace Angela,
Present, ma'am.
Mark Daniel,
Yes, ma'am.
Santosh,
Present, ma'am.
Giovin,
Present, ma'am.
Darwin,
Present, ma'am.
Abhishek,
Yes, ma'am.
Maunika,
Yes, ma'am.
Dunamis Blesson,
Yes, ma'am.
Srinivasa Reddy,
Present, ma'am.
Abhishek Abraham,
Yes, ma'am.
Panduranga Prabhu,
Yes, ma'am.
Hari Gokul,
Present, ma'am. Are you present, ma'am?
Prasanna Kumar,
Present, ma'am.
Jerlin Lijo, Pavani,
Yes, ma'am.
Arun Kumar,
Yes, ma'am.
Sasidhar Reddy,
Present, ma'am.
Johnson,
Present, ma'am.
Austin,
Present, ma'am.
Kambam Sanjay,
Present, ma'am.
Monish,
Present, ma'am.
Peter,
Present, ma'am.
Sri Sai Rahul Reddy,
Present, ma'am.
Nahasai Nikitanjani,
Present, ma'am.
Kavin,
Present, ma'am.
Singham Shetty Johnson,
Present, ma'am.
Revanth, Solomon Raj. Yeah, Soumya, I have marked you present.
Okay, ma'am. Thank you, ma'am.
Solomon, you have made here in the chat box, okay. Sharon,
Present, ma'am.
Srujan,
Present, ma'am.
Srikanth, Vishwamohan, Roshan,
Present, ma'am.
Yes, ma'am.
Present, ma'am.
Vishwamohan present. Roshan,
Yes, ma'am.
Tirumalai Nambi,
Present, ma'am.
Miduna, yeah, present. Hamsavardhan,
Present, ma'am.
Ma'am, you didn't call my name, ma'am.
Revanth, I have called you twice or thrice.
Yeah.
You are not there, I think so.
I'm present, ma'am.
I have called you twice or thrice. Hamsavardhan,
I'm present, ma'am.
British,
Present, ma'am.
Hasban Gibson,
Present, ma'am.
Darla,
Present, ma'am.
Danush,
Present, ma'am.
Sibi present. Hariharan.
Present, ma'am.
So the absentees are 1080 and 1257.
Ma'am, 1257, ma'am.
Where have you gone, Srikanth? When I called you, you have not responded. 1080, Sriram Prasad.